And we'll transit to next presentation again from me, I hope. But I promise this is the last one from me, today at least. This time I will present the design example from TGB2 on the Solnay structure. The problem is given on the picture here. It's very simple, new vertical slope wall with a hard facing. Some of you may know it because it's based on German Grundbautaschenbuch Teil 3. The basic, it's simple because there is only one soil layer and no groundwater table in the zone of the influence. Regarding the soil nail structure itself, the layout of the soil nails is given here. What's important, we got as the basic assumption 50 kilonewton per meter of the representative value of pull-out resistance, and it's based on extensive comparable experience with no project-specific test. And in the case the limit states design is or checks are not fulfilled, the variable is the length of the soil nails. Going back to this list of the limit states I showed previously, most of them are usually checked for this, and it was the same case for this design example, but for this presentation I will focus on the stability, rupture of the soil nail, and pull-out resistance. Usually when we start design soil nailed structure, we assume some kind of a layout of the soil nails, their geometry, and their pull-out resistance. Here it was a bit easier because we already had this 50 kilonewton per meter as the representative value, and we can check in the table in the annex which formula can we use in this case for comparable experience. The last one, the RPO, the partial factor for pull-out resistance, is always 125. But regarding the model factor, we go to the table with the model factors, and for the extensive comparable experience without site-specific tests, we have a value of 1.4. And then you all know this very simple formula, no rocket science here, but it's interesting that we are going down from 15 kilonewtons per meter of the representative value to 29 kilonewtons per meter of the design value. And if we want to check it for one specific soil nail, it's 90 kilonewtons of the pull-out resistance, obviously behind the failure surface. But let's be honest, it's not always so easy, and not very economically optimized. So, and as I showed you, we have many methods of determination of the pull-out resistance, and to compare it, thanks to Didier Girelli, we are still thankful for this data. We have some real project data with the set of tests and the alternative calculation using the comparable experience. In those tables, you can see the results from those tests. And based on the formula I showed previously, the design pull-out resistance would be 153 kilonewtons for this given condition and given geometry. If we used let's see, design by calculation method based on comparable experience, we would assume a value of tau PO 700 kps, doesn't matter. But at the end, our design value of pull-out resistance would be 81 kilonewtons. So it's almost 2 times smaller. So simply because all these sets of partial factors, model factors, are to ensure the proper, let's say, safety margin. So perhaps it's worth of investing a bit more money at the beginning of the design process to, at the very end of the design, saves loads of money. I think this is some mindset which has to be changed, for example, in Poland. Then, regarding the structural resistance, we use, as it's referred in clause 10, we use the formulas from Eurocode 3 part 5. And regarding the loss of the sacrificial loss to be used, we are also referred to this table. And for the given conditions, it's the value of 1.2 millimeter per the whole diameter, which is much smaller than in EN14 490. So we shall consider it discussing the national annexes. At the very end, we have 220 kilonewtons of the structural resistance. Having all this defined, we can check the stability. And as we already discussed it here today, we have these different methods we can use, plus others, because this list is not exhaustive. We can use some other methods, but for this example, I used LAM methods according to these calculation models. And for all these calculations, the set of partial factors are gathered in this table. And actually, filling this table was one of the most painful job during this design example. You know, looking into three documents. It's not easy, and as I heard yesterday, today, it's not only my problem. Yeah, you may notice that obviously I checked, I use MFA approach, but I also checked RFA for two reasons. One is there are still some countries using it. The second one, it's an option for internal failure mechanism. So, for example, for the facing. And as in that kind of analysis, we not necessarily differentiate between compound, internal, external. Just to make it an one analysis, I run it like this. Here you can see some of the results I got. The difference in the over-design factor is not noticeable for both the different partial factoring approach and the different calculation models. Here also some additional values I took out for the external stability, which is obviously done parallelly in these calculations. And for the decisive, which I believe it's the decisive failure model, the ultimate limit state condition is not fulfilled, so obviously the Laurent has to be longer. But it's also, I think, crucial that what influences the results even more than different partial factor set are the calculation models. So we are again back to this very basic discussion that we need to be engineers and know what could be the decisive failure model. We cannot blindly use one of those. And also, obviously, it's not only the over-design factor, but the model we use has a big impact also on the total length of the nail and their structural resistance. So at the very end of the day, we are still talking about money, sustainability, etc. And because I mentioned it here a couple of times already, the method we determine the pull-out resistance is connected to model factor, which has a very different values. So obviously it will influence the results of the stability analysis very much. That's why I also run some extra analysis for these different model factors, and you can notice that for the whole structure, the difference in the final length of the nail can be up to even 25 or some, between 86 to 100 more than 100% of the original length. So it's worth considering again to do this test before before the design. For the exercise, I also performed the bearing and sliding resistance verification. Usually it's not the case unless very specific design situation. For example, the layer of very weak soil at the base of the wall. You can see the results in the report. The same for the loss of equilibrium. I wouldn't say it's a standard procedure. When we have all these calculations, we can go to check the resistance of the soil nail. But before, I realized that these are the supporting elements, so I shall check these elements according to these two formulas. So I run the SLS calculation just to be sure that we are on the safe side. After factoring the result tension load in the soil nail. Then we can check the resistance, so we compare the tension load versus the pull-out resistance and the structural resistance. It was not fulfilled, so it's obviously, and the decisive factor was the pull-out resistance, so it means it has to be long, the soil nail has to be longer. I put it here with the formulas, but in practice it's done automatically in most of the softwares we use. But here for the need of the exercise, I did it. Obviously, it will conclude my presentation here, but obviously in the real project, we also have some other considerations like connections on the soil nails and the facing design as well. For both of them, you have to calculate the nail head, the load at the nail head. Clause 10 gives reference to these two, I don't know what happened here, to these two guidance. I also I used the German approach. So to conclude, as I said, the provisions are very general. No guidance is given, to be honest, but there are many methods and calculation models we can use. So I have this this feeling that I can somehow fit my practice or international practice into this framework. We have to be aware that the stability calculation, for the stability calculation, the model of calculation is the most important, and it would not be solved in one design code. The method of the pull-out resistance can be also very impactful on our results, and I appreciate very much the material and corrosion protection aspects, how they are covered in Eurocode 7 Part 5. There are some, let's say, issues I think can be solved on national level. Maybe not solved, but the guidance can be given. So thank you very much for your attention again.